Welcome back to our lesson practice review, where today we are going through chapter 2, lesson 6, practice. To start off, we'll summarize what lesson 6 was all about. Maybe this new idea to you where we have this scary topic called imaginary numbers. And basically, what we're talking about when we say imaginary numbers is that we are going to be taking the square root of -1. Taking the square root of a negative is impossible technically, because when I'm trying to take the square root, I'm looking for two things that multiply together to get the number on the inside. And for example, the square root of -1, like I can't do -1 and 1 because those aren't the same thing. I can't do +1 and +1 because that would give me +1. And I can't do -1 or -1 because that would also give me +1. And so there's really no square root of a negative number, which is why we have this introduction to what we call imaginary numbers. It's going to be a little bit of a challenge to wrap our heads around why, but let's focus on the two main things that we need to understand is that the letter I is going to now represent the square root of -1, which means that if I were to use I squared, would mean the square root of -1 times the square root of -1, which now just the square roots cancel out and give us just -1. And so those are the two kind of main things here, is that I is the square root of -1 and I squared is just -1. So an example problem here is pretty good to show you here. If we're trying to solve this equation, we divide both sides by 6. We'd take the square root. And really specifically here, when we're taking the square root of -9, that's the same thing as the square root of 9 times the square root of -1. Well, the square root of 9 we know is plus or minus 3. And the square root of -1 we now know is I. So it kind of breaks it up into two parts here when we are square rooting these numbers. When we're square rooting 9, just remember that that's the same thing as the square root of 3 times the square root of 3, and that's why the square roots cancel out, leaving us with just 3. So we get two answers, plus or minus 3i, and we're going to need to be able to know how to do this kind of stuff. So without further ado, let's try and get some practice. For problems number 1 and 2, we have a function f of x is equal to x squared plus 4. Determine the zeros of f of x. To determine a 0, I'm just plugging in 0 for our output, or our f of x. In that case, I'm going to subtract 4 from both sides. I'm going to take the square root of both sides, and when I do that, that's the same thing as the square root of -1 and the square root of 4. I know the square root of 4 is just plus or minus 2, and the square root of the square root of -1 is just I. And so I get my two answers here of x equals positive 2i and x equals negative 2i. For number 2, are the zeros of f of x also x-intercepts? And the answer to that would be no. There's a couple different ways to explain it, but basically if we were to look at this equation that we started with, x squared plus 4, f of x equals, if we were to look at the graph of that, right, that's normally we have it here. This plus 4 is shifting it up 5 units. And so we can kind of see that we don't have any x-intercepts. Anytime we get imaginary numbers, that tells us that these are not actual intercepts. They are just our imaginary solutions. For problems 3 to 5, rewrite each number using I. So again, I'm going to kind of write this as breaking it up into the square root of 16 and the square root of -1. So I'm really just pulling this negative out to make it so that I can just rewrite this as I. Now, just as a heads up, when you are solving something and you take the square root, that's when we have to do that plus or minus. Right now, we are given the square root here, and we're going to assume that it is positive. Therefore, instead of giving us plus or minus 4i, I'm just going to call this answer 4i. Same thing with number 4 here. I'm going to break this up. I'm going to call this square root of -11 times the square root of -1, which is just I. And so this does not, square root of just positive 11 here. And I can't simplify this, so I'm going to put the I in the front so that it doesn't look like it's on the inside anymore, and call this our simplified answer. Now we get to the tricky ones when we're simplifying square roots. Yes, we could make it exactly the same as the last one, calling this part I and saying I root 12. But what's important for us to be able to do is to simplify square roots. The way that we do that is we are going to be breaking it down. Oops, I'm changing the color of the wrong thing here. Breaking this down, I know that this is the square root of 4 times the square root of 3, and I know that the square root of 4 is just 2 times 2. So really this one here, the square root of 4, this ends up becoming, I can pull that 2 out to the front and the I out to the front, and we leave that square root of 3 here because I can't pair that up with anything. So I get 2I root 3. For number 6, select all true statements. I is equal to the square root of negative 1. Yes, that's the basis of this whole lesson. Square root of negative 1 is an example of an imaginary number. Also, yes. I squared is negative 1. Also, yes. We're on a roll here. These are all like the main things that we need to know for this lesson. For D, the square root of 3 is an example of an imaginary number. No, imaginary numbers are when we square root a negative. That's not a negative number. The solutions of the equation x squared equals 25 are imaginary. That's also not true because when I take the square root of a positive number, I do not get an imaginary number. Problems 7 through 9. Solve each equation algebraically. Use I to express imaginary solutions. And we're going to go ahead and show our thinking. See if I have enough space to do this. So the first thing I'm going to do here is I'm going to subtract 100 from both sides, which gives me a negative number. I then take the square root of both sides, which then gives me plus or minus square root of negative 100. To simplify this, it's the same thing as the square root of 100 times the square root of negative 1. I know that the square root of 100 is 10, and the square root of negative 1 is I. So again, I like to leave my answers like this. Oftentimes you'll see them broken down into its actual two separate answers, which is positive 10i and negative 10i. Number 8. First thing I'm going to do, divide by 7. X squared is equal to negative 4. Take the square root of both sides, which gives me plus or minus the square root of negative 4. I know the square root of 4 is just 2, and the square root of negative 1 is just I. And so I get my two solutions of x equals 2i and x equals negative 2i. Again, you can write your answer as either of these. I think the book usually kind of looks at it like this. I oftentimes am just lazy, so I leave it as plus or minus 2i. All right, number 9. First thing I'm going to do here is subtract 19 from both sides. Divide both sides by 2. Take the square root. This breaks up into the square root of 6 and the square root of negative 1. I cannot simplify the square root of 6, but I know negative 1 represents I. And so my two answers are x equals positive I root 6 and x equals negative I root 6. All right, number 10. Here's a graph of g of x. Which translation of g of x has imaginary zeros? So imaginary zeros here would mean that we would need to not have any x-intercepts. And so really what we would need to do is either reflect this or shift it up a certain number of units. And to do that right now, this is at negative 3. So I need to be moving this up more than 3 units, because if I move this up 1, 2, 3, 4 units, then my graph now looks like this, where it has 0 intercepts, which means my zeros would be imaginary. The one that moves it up by 4 is g of x plus 4, because remember, this moves it down by 4, this moves it left by 4, and this moves it right by 4. So for number 11, write a quadratic equation that would have the solutions x equals 5i and x equals negative 5i. So a couple ways to do this. I'm going to give you the kind of basic maybe way that you might think about it originally, and then I'm going to go through the maybe a precursor to something that we use in the future. And so to start off, to write the quadratic equation, I know that I need to take the square root of a negative number. So I'm going to have x equals the square root of a negative number. And then since I'm taking the square root, I know it'll be 5 times 5, which is 25 here. So then I'm going to square both sides, and I get x squared is equal to negative 25, or I could even say x squared plus 25 is equal to 0. So those are equations that would give me solutions of 5i and negative 5i. The other way to do this, and again, I'm probably going about this a little bit too in depth, but I kind of want to talk about it anyways, is that when I look at these individually, these are equations that help find the two factors of my quadratic. If I were to subtract 5i from both sides in this equation, I'd get x minus 5i equals 0. And this is us working backwards to get our factors here. And now I can actually take these two factors and multiply them together, which when I do that, I'll use a box here, x minus 5i, x plus 5i, negative 5xi. Now this is looking ugly here, but these two things, when you add them together, become 0. And then this last one is negative 5i squared. And so what I get here is x squared minus 5i squared. 25, because 5 times 5 is 25. And what we learned again from this summary or from this lesson is that I squared is technically just equal to negative 1. So I'm multiplying negative 5 times negative 25 times negative 1, which gives me just x squared plus 25. And now I'm back to where I started over here. So I may be going a little bit too in depth on this one here, but it's a good one to kind of go through and see as well. All right, now to our spiral review. Number 12. We're solving this algebraically, and I need to show my thinking. So first one here, I'm going to square root both sides, which gives me plus or minus 2. Then I subtract 1 from both sides, gives me x equals negative 1 plus 2, x equals negative 1 minus 2, which my solutions are x equals 1 and x equals negative 3. For 13, divide by 4 on both sides. Take the square root, which then gives me x minus 6 equals plus or minus 5. Add 6 to both sides to get 6 plus or minus 5, which then gives me my answers of 6 plus 5, 6 minus 5, x is equal to 11, and x is equal to 1. And last problem here, looks to me like this one's going to be something that might be factorable, so I'll throw this one in the box to see what we get. First term, first box, last term, last box. Then my two terms that I'm splitting this up into have to multiply to negative 8x squared and add to negative 2x, which would be negative 2x and positive 2x. Sorry, negative 4x and positive 2x. Stumbling over my words a little bit today. Negative 4 and 2. So now we got x minus 4 times x plus 2 equals 0. And this is kind of what I was saying earlier about this light blue equation up here, is that once we have the two factors, we're then splitting it up and setting them both equal to 0, right? So we can kind of see that we got the things on the outside, and now using the zero product property, we set each piece equal to 0 to solve. So my answers here are x equals 4 and x equals -2. That wraps up our Chapter 2, Lesson 6 practice. As we continue talking about quadratics, we now have been introduced to imaginary numbers, and we will pick up where we left off on Lesson 7.